Logarithmic equations. Yeah, I know. For some people, those words sound like something invented just to make math harder. But what if I told you they're not a monster? They're just a puzzle. And all you need is the right toolkit to solve them. So let's dive in and build that toolkit together, step by step.
So here's our game plan. First, we're going to look at the challenge so we know exactly what we're up against. Then, I'll give you the single most important strategy. I call it the golden rule. After that, a super important safety check to keep you from making easy mistakes. Then, we'll open up our toolkit and look at the techniques. And finally, we'll wrap it all up with the key takeaways.
All right, let's kick things off with Section 1, the challenge. Before you can solve any puzzle, you gotta understand what it is, right? So what exactly is a logarithmic equation? It's actually pretty simple. A logarithmic equation is just any equation where the thing you're looking for, that x, is trapped inside of a logarithm. That's the whole game. Our mission is to bust that x out of its logarithmic prison. Okay, now for what is, I think, the most important part of this whole thing. If you forget everything else, remember this. This is the ultimate goal, the key that unlocks pretty much every single problem. We're calling it the golden rule. Let's look at a really basic one. If log base 2 of x equals 3, what's x? Just remember what a logarithm is asking. It's saying 2 to the power of what gives me x? Well, the equation is telling us that what is 3. And yeah, of course, the answer is 8. Now that's a nice, simple one. But most equations you're going to face aren't this straightforward, which is why we need a much more powerful universal strategy. And here it is, the golden rule. Your number one goal almost every single time is to get the equation into this exact format. One single logarithm on the left and one single logarithm on the right with the exact same base. Pretty much everything we're about to do is just to get our equation to look like this. And here's why that rule is so powerful. Once you have that perfect format, log base a of a equals log base a of b, you can basically just drop the logs. I like to call it de-logarithmizing. You're just left with a equals b. All that log complexity just vanishes and you've got a much easier problem to solve. But hold on. Before we start rearranging equations, we have to talk about safety. This step is absolutely non-negotiable. And trust me, it's going to save you from getting the wrong answers down the line. Think of a logarithm like a machine with one critical safety rule. It only takes positive numbers. You can't feed it a 0, and you can't feed it a negative number. It just won't work. So the argument, that's the stuff inside the parentheses, has to be greater than 0, period. Any answer for x that breaks this rule is not a real solution. You gotta throw it out. So you've got two ways to handle this. Option 1, you can figure out the legal values for x, the conditions, right at the very beginning, before you do anything else. Option 2, you can just solve the equation, get your potential answers, and then plug each one back into the original equation to see if it actually works. That's called the final check, or zgusha. Both ways work perfectly fine, just pick the one that feels right for you. Okay, we've got our goal, the golden rule, and we have our safety check. Now it's time for Section 4, the fun part, the toolkit. Let's look at the actual tools we're going to use to get these equations into shape. Your main tool, your number one go-to, is going to be your knowledge of logarithm formulas. You know, the sum rule, the difference rule, the power rule. These are your best friends for combining a bunch of logs into one clean single log. That's what gets you closer to the golden rule. And this example shows the whole process perfectly. We start with this kind of messy equation. So step 1, we use the log formulas to combine the left side and simplify the right side. And look at that, we have a single log on both sides. We've reached the golden rule. That means we can go to step 2, de-logarithmize. We just drop the logs. Step 3 is just solving the simple quadratic equation that's left, which gives us x equals 10. But we're not done. Step 4, the safety check. The conditions from our original equation tell us x has to be bigger than 7. Well, 10 is bigger than 7, so we're good to go. It's a valid solution. Now, another really powerful tool, especially for trickier equations, is substitution. If you see the same exact log expression popping up multiple times, you can just temporarily swap it out for a simple letter, like y. This can turn a really confusing-looking log equation into a simple quadratic you already know how to solve. It's a great trick. Okay, one really important warning here. You have to watch the notation. Log squared of x, where the little 2 is on the log, means you find the log of x first, and then you square that whole answer. That is totally different from log of x squared, where you square the x first. Confusing these two is probably one of the most common mistakes people make. So, we've covered the goal, the safety rules, and the tools. Let's bring it all home in our final section. Key takeaways. Think of this as your simple go-to checklist for solving any of these problems. Here it is, the whole process in 5 steps. 1. Always know your goal. Get that single log on both sides. 2. Do your safety check. Figure out the conditions for x so you know what answers are even possible. 3. Use your tools, your formulas and substitution, to simplify and get to that goal. 4. De-logarithmize and solve the simple equation that's left. And finally, step 5, verify. Check your answer against those conditions you found in step 2 to make sure it's a real solution. So you see, logarithmic equations aren't some scary monster. They're just a puzzle with a very clear set of rules. And now you have the strategy, the safety checks, and the tools. You have the whole toolkit. So the only question left is, are you ready to solve it?